Hello guys, welcome back to my YouTube channel. Today we will be discussing correlation analysis. What is it all about? It is a way of relating two continuous variables. It could be ratio or interval variables. There are two main types of correlation analysis, but in this video, I will be just focusing on the Pearson correlation. Pearson correlation is a statistical analysis tool to find relationship of two continuous variables. On the other hand, Pearson correlation helps you find monotonic relationship between two continuous or ordinal variables. Ordinal means your data has an order. It does not allow a data to occur between fixed data points. Correlation analysis has a resulting scale. It ranges from -1 up to +1. If you got a 0, it means there is no correlation. With Pearson, the result can occur in any point within the range. However, with Spearman, it usually goes to +1 or -1. Together, with the use of correlation analysis, we use scatterplot to visualize data. In correlation analysis, we have coefficient, which is the basis of how low or high is the relationship or correlation between two variables. We have the standard Greek letter rho to denote the coefficient, but most of the time we just use the small letter r. Whatever the resulting correlation coefficient, we will interpret it using this list. Remember, 0 means that there is no correlation between two variables. If the coefficient is between 0.1 to 0.19, then it is interpreted as very low correlation. 0.2 to 0.39 means low correlation. 0.4 to 0.59 means moderate correlation. 0.6 to 0.79 means high correlation. 0.8 to 1.0, very high correlation. Correlation can be positive or negative. Positive means if one variable increases, the other variable will also increase. If it is negative, one variable moves in the opposite direction of each other. How will we perform hypothesis testing? First, we need to state our null hypothesis. There is no correlation between the two variables. H sub 0 rho underscore Pearson equals 0. H sub 0 rho Spearman equals 0. Remember, rho can be substituted with small letter r. The alternative hypothesis will be there is a correlation between the two variables. H sub a rho sub Pearson not equal to 0. H sub a rho sub Spearman not equal to 0. If it is not equal to 0, it means that the value can fall at any of the following ranges. But if it is 0, it means there is no correlation. Let us make the first sample. Let me open the orange 3. Remember that our dataset is the transformed version of the diabetes RCT file. We also use this in the student t-test, chi-square, and analysis of variance. To perform the correlation analysis, click this right side area of the widget, then drag it downward and rightward. When you release the left click, a pop-up menu will appear. Just type correlation, then click it. Inside the correlation, you can choose whether you want to use Pearson or Spearman. Most of our continuous variables have interval. It does not have an order, so it is fitting to use Pearson correlation. In correlation analysis, it is better if we can see the scatter plot and the regression line. If you can see these broken lines on the right of the widget, left click, then drag to the right, then release. Type scatter plot. Click on the scatter plot. This message will appear. Edit links. We will just use the default where the data in the correlation widget is linked to the data in the scatterplot widget. Then click OK. We check the scatterplot. In the x-axis, we designated it as initial HbA1c. Then, in the y-axis, here it is HbA1c 6 months. The resulting R coefficient is 0.08. Based on the coefficient interpretation, it is here between 0.01 to 0.19. It is very low correlation. Let us formulate a scientific inquiry. Is there correlation between initial and 6-month HbA1c level, our null hypothesis will be there is no correlation between initial and 6-month HbA1c level. The alternative hypothesis will be there is a correlation between initial and 6-month HbA1c level. Our rho or R coefficient is 0.08. We interpret this as a very low positive correlation. We can therefore conclude that there is a very low correlation between the initial and 6-month HbA1c level. So that is the first correlation analysis. We will do this for all the continuous variables in our dataset. I will just speed up the process. Later, we will discuss the results from the analysis. Please remember that in correlation analysis, correlation does not mean causation. It does not mean that one of the two variables is the cause of the other. Correlation just means that there is a relationship in the movement or values between the two variables, but it does not mean that one is affecting the other. Okay, so we finished the speed up process. Now we will check all the things that we have accomplished. Let us look back on the very first comparison. We compared the initial and 6-month HbA1c level. The initial level is in the x-axis. The 6-month is in the y-axis. This is our regression line, and the Pearson coefficient is at 0.08. It means that there is a very low positive correlation. We can conclude that there is a very low positive correlation between initial and 6-month HbA1c level. Next, we compare initial and 12-month HbA1c level. It looks slightly higher. This is the regression line. The Pearson coefficient that we got is 0.14. We will still interpret this as very low positive correlation. We can conclude that there is a very low positive correlation between initial and 12-month HbA1c level. Next, we compare the initial HbA1c and initial systolic blood pressure. Our null hypothesis states that there is no correlation, while the alternative hypothesis states that there is a correlation. The Pearson coefficient that we got is negative 0.15. Okay, I don't know why R is written inverted. The regression line has a downward slope. It means that if the value of initial HbA1c increases, the value of the initial systolic blood pressure will decrease. Our interpretation is very low negative correlation. We can conclude that there is a very low initial correlation between initial HbA1c level and initial systolic blood pressure. How about initial HbA1c and 6-month systolic blood pressure? It looks the same. There is a downward regression line. The coefficient that we got is negative 0.1, which means there is very low negative correlation. Next, between initial HbA1c level and 12-month systolic blood pressure, we have a coefficient of slightly positive of 0.01, very low positive correlation. Next, between initial HbA1c level and diabetes duration, you can see here that our regression line goes downward. As the value of initial HbA1c increases, the value of the diabetes duration decreases. The coefficient that we got is negative 0.24, low negative correlation. How about between the initial HbA1c level and age? You can see the coefficient as negative 0.05, and then the regression line is near horizontal direction. We have a very low negative correlation. Next, between initial HbA1c and BMI, the coefficient that we got is negative 0.15, which is very low negative correlation. Between initial HbA1c and literacy score, as you can see, as the initial HbA1c level increases, the literacy score decreases. The resulting coefficient is negative 0.12. You can see the regression line going downward. We interpret this as very low negative correlation. Next, between initial HbA1c and difference or improvement. Remember that the variable difference comes from the difference between 12-month HbA1c and initial HbA1c. If we will go back to our orange 3, we can look at the data table. The difference is the last column. Its component is the 12-month and initial HbA1c level. Here in our scatter plot, it is very logical that there is a big correlation because one of the component of difference is the initial HbA1c level. You can see the regression line going upwards. The resulting coefficient is 0.7, which means that there is a high positive correlation. We can conclude that there is a high positive correlation between initial HbA1c level and improvement. Next, between 6-month and 12-month HbA1c level, the Pearson coefficient we got is 0.73, which means there is a high positive correlation. Next, between 6-month HbA1c and initial systolic blood pressure. Logically, these are two different entities. One is about sugar and the other blood pressure. However, for the sake of practice, we will still correlate them. The coefficient that we got is 0.03. We interpret this as a very low negative correlation. As you can see, the regression line is almost horizontal. Between 6-month and 12-month systolic blood pressure, we can see that the regression line is going up and the resulting coefficient is 0.11, which means that there is a very low positive correlation. Between 6-month HbA1c and diabetes duration, the resulting Pearson coefficient is 0.18. This means there is a very low positive correlation. Next, between 6-month HbA1c and age, we can see that the regression line goes downward and the coefficient that we got is negative 0.22. This means that there is a low negative correlation. Next, HbA1c level and BMI. We can see the regression line almost horizontal. The resulting coefficient is negative 0.04, which means that there is a very low negative correlation between HbA1c and literacy score. The regression line is slightly going upward. The coefficient is 0.06. This means that there is a very low positive correlation between 6-month HbA1c and difference. We can still say that it is logical that they have correlation because they both measures the HbA1c level. You can see that the regression line is going down. The Pearson coefficient that we got is negative 0.47, which means that there is a moderate negative correlation between 12-month HbA1c level and initial systolic blood pressure. The regression line goes downward. The coefficient is negative 0.12. We interpret this as very low negative correlation between 12-month HbA1c and 6-month systolic blood pressure. The regression line goes downward. The Pearson coefficient is negative 0.14. This means that there is a very low negative correlation between 12-month HbA1c and 12-month systolic blood pressure. The regression line goes upward, but the Pearson coefficient is 0.04. It has a very low positive correlation between 12-month HbA1c and diabetes duration. The resulting coefficient is 0.08, which means that there is a very low positive correlation. Next, between HbA1c and age, the regression line goes downward. The coefficient is negative 0.27. This means that there is a very low negative correlation. As the value of the 12-month HbA1c increases, the age decreases. Or we can interpret it as the patient gets older, the HbA1c level decreases. Next, between HbA1c and BMI, we have a coefficient of negative 0.06, which means that there is a very low negative correlation. Between HbA1c and literacy score, the regression line goes upward and our coefficient is 0.14. This means that there is a very low positive correlation. Next, between 12-month HbA1c and improvement of diabetes. Again, this is logical since 12-month HbA1c is a component of the difference. The regression line goes downward. The Pearson coefficient is negative 0.62. There is a high negative correlation between 12-month HbA1c level and improvement. Next, initial 6-month systolic blood pressure. You can see that the regression line goes upward. The resulting coefficient is 0.27, which means there is very low positive correlation. It is just the same between initial and 12-month systolic blood pressure. The coefficient coefficient is 0.27, low positive correlation. Between systolic blood pressure and diabetes duration, the coefficient is 0.19, very low positive correlation. Initial systolic blood pressure and age, the coefficient is 0.07, very low positive correlation. With body mass index, the coefficient is 0.11, very low positive correlation. With literacy score, negative 0.06, there is very low negative correlation. With difference or improvement, we have a coefficient of negative 0.03, very low negative correlation. You can see that the regression line is almost horizontal. And 12-month systolic blood pressure, the regression line goes upward. The coefficient is 0.38, which means there is a low positive correlation. Systolic BP and diabetes duration, the coefficient is 0.04, very low positive correlation. Systolic BP and age, the coefficient is 0.01, very low positive correlation. Systolic BP with body mass index, the coefficient is 0.08, very low positive correlation. With literacy score, the coefficient is negative 0.16, very low negative correlation. Systolic BP and difference, the regression line is almost horizontal. The resulting coefficient is 0.02. There is a very low positive correlation. Diabetes duration, the coefficient is 0.03, which means very low positive correlation. Age, the coefficient is 0.1, very low positive correlation. Body mass index, the coefficient is 0.04, very low positive correlation. Literacy score, the coefficient is negative 0.15, very low negative correlation. The difference again, negative 0.02, very low negative correlation. Diabetes duration and age, the Pearson coefficient is 0.3, low positive correlation. You can see here in the variable diabetes duration, each data point just belongs to one column. It means that there is no in-between values. Here in the variable age, kinda looks the same. Let us find out if the Pearson coefficient will be the same if we use the Spearman correlation. Let's go back to our orange 3. Here, click the correlation widget, choose Spearman, go to the scatterplot widget, then choose diabetes duration in the x-axis and age in the y-axis. The Spearman correlation that we got is 0.3, which is the same with Pearson. Between diabetes duration and body mass index, the resulting coefficient is negative 0.04. Very low negative correlation. Between diabetes duration and literacy score, you can see that the regression line is horizontal. Then the coefficient is negative 0.00. Maybe its value is more than 3 decimal places. We can just consider this as a pure zero. We can just interpret this as no correlation. Next, diabetes duration and difference or improvement. The coefficient is negative 0.25, low negative correlation. Between age and BMI, the regression line is going down. The Pearson coefficient that we got is negative 0.33, low negative correlation. Between age and literacy score, we have a downward regression line and a coefficient of negative 0.2, which means there is low negative correlation. Between age and improvement, there is a very low positive correlation. Body mass index and literacy score, the resulting coefficient is 0.05. There is a very low positive correlation. BMI and improvement, the coefficient is negative 0.08, very low negative correlation. Literacy and improvement, the coefficient that we got is negative 0.19, very low negative correlation. That will be the end of our video for today. If you have learned a lot, please like this video and subscribe to my channel. We will learn statistics again next time. And remember that correlation does not mean causation.